Good. Oh,
Okay. Are we good?
yeah, we're good to go.
Okay, cool. Hey everyone, welcome to our 9th and final session of Bootcamp. So these first 8 sessions, we taught you a lot of techniques about how to write code. And this, we're going to be talking about how to write good code. So we're going to be talking a lot about code quality. So on our agenda today, we're first going to go over unit testing, which is just a great way to make sure that the code that we write is behaving how we expect it to. And then we're going to go into code etiquette, which is a lot of smaller topics about how to write good code. And as I said, this is our last bootcamp session. So we're at session number 9.
Sweet. Thanks, Vince. So as mentioned, first thing we're going to cover today is actually unit testing. And so we should be good to go ahead and get started and go right into that. So before anything else, there's a bunch of different types of tests. I'll briefly talk about some of these, but the main one we're going to be focusing on today is unit testing. I guess so design on all of the nonprofit projects, they're going to be doing usability testing, also known as user testing. And they're going to be working directly with the nonprofits and making sure that I guess that the designs they have are easy to understand and work well for our nonprofits. However, for us, we're developers, so we're going to be writing unit tests. And what this is going to do is allow us to write quality code that is kind of future proof. I guess, but by writing unit tests, we don't have to always manually test things. And if we change our code down the line, we don't have to recheck our that we didn't break functionality elsewhere, as unit tests can go ahead and do this for us. Some other types of testing are integration testing, acceptance testing, accessibility testing is a pretty important one as well. You might do this on your projects, especially the progressive web app one. That's going to need to be accessible, I guess, regardless of your internet connection. So you'll probably do that in that application. And then end-to-end testing is also great. You might do some of that on your front end. But without further ado, we'll move on to why you should write unit tests. So unit testing has a lot of kind of key benefits. The first one is it ensures that all of the code we write is of a high quality. By writing unit tests, we are also checking that our code is consistent. So those two are big ones, especially with a lot of us this might be the first big team project we've worked on. By writing unit tests for our code, we're going to ensure that it works as expected and it consistently works as well. Another huge benefit is there's less technical debt. And if you are unfamiliar with what technical debt is, that kind of means that you might save time now by cutting corners on some of your code early on, and that can come back to bite you in the butt a lot later during your project. And so writing unit tests is a kind of a way that kind of counters that. And then another benefit is it future proofs our code. So let's picture like 10 years down the line, say one of the teams has, I guess one of the teams has a bug that gets created in their app. We can we'll still have these unit tests so that future developers who might be maintaining our sites won't break anything when they test it and when they fix that bug. So that's huge. And then another final benefit is it provides documentation. Sometimes it can be kind of hard to read other people's functions and understand what they do, but oftentimes unit tests are a great starter place. And like, if you're trying to figure out what a function does, a great first place to look is what their unit test is doing. And then unit tests, they are great, but it's kind of unrealistic and unpractical and kind of a waste of time to cover 100% of your code. Maybe in some of your classes, I know in my 101 class, we had to write unit tests that covered 100% of our code. That's kind of unnecessary and is honestly a waste of time. But there are very useful times when you should be writing unit tests. I think the most important one is for mission critical code. And what that means is the code that is like very important to your application. So if it's a volunteer management system, you're going to want to make sure that the like login and the sign up works great, because that's like very important for your application. So the most important code is probably the code that should be tested. Other times you should write unit tests are functions that take data in. That's pretty self-explanatory. And then code that is deterministic. And what that means is that functions that have inputs that always have the same output, those are good ones to test as well. An example of a code that's not deterministic is maybe like a random, if we were calling an API that just gets a random recipe. You can't really test that very well because it gets a random thing. So you probably don't want to test that. But if your functions are going to return a consistent result, you're going to want to make sure to test that function as well. And then how to write unit tests. So this is kind of a big topic, and there's a lot of different resources you can use to do this. When testing JavaScript, and that includes React as well, Jest is a super beneficial tool to use. It's an npm package, but there are other ways to write unit tests as well. I know Mocha is another package, and there's also Cypress, which is really good at testing front-end code and end-to-end testing. However, Jest works well for JavaScript and will work great for us in our projects. So I guess ideally, it's best to write unit tests before you write your functions. I'm sure you've heard this in your classes, and it's a key part of test-driven development. And I agree with that statement where it is ideal to write your tests before you write your function, but I get that that's not always practical because you might not know what your function looks like until you write it. So writing a test after is still beneficial for a lot of the same reasons we saw on the first slide. And we want to test a few different things. We want to always test that valid inputs return expected outputs. And another important thing is we want to test that invalid inputs return expected errors as well. So we don't always want to test that our code works. I guess the perfect code with a valid input works. We also want to test code that might cause an error, and we want to make sure that that actually returns an error. That's just as beneficial as a test that checks that your code works. So we're going to move on to arrange, act, assert. And this is kind of how the format you'll use for writing your tests. So whenever you do write a unit test, and we'll get into a demo of this in a little bit, you kind of want to start with 3 parts. So arrange, that's kind of where you're going to be putting all of your test data. You want to declare your expected result as well there. And then in your act, that's kind of going to be where you're calling the function or method that you want to test. And then your assert is usually going to be probably the easiest part of your test. And that's just going to check that the value returned from the act will be matched with the result that we expect. And one other note before we move on to the demo is it's really, how do I say this? I know writing tests can sometimes be easy if you like return data. So let's say if like we run a function and it returns 4, we might just run that function, see that it returns 4, and then put that in our assert statement. That is not how we want to be writing unit tests. We want to make sure we write the expected values before our code actually runs, so that way we'll know that it's working as we expect it to. And then we should be good to move on to our demo. And I already wrote some starter code here, if I can get to it, and I'll just briefly talk over what this is as well. So I guess one thing you should do is you have to install Jest. You can run the command npm I Jest. I already ran it, so I'll just run it again. Nothing should happen. And we should see in our package.json that Jest exists. So then we also have 2 functions. we'll start with functions.js, and we'll go ahead and write a test for it. So first thing it is it's just a very, very, very simple function where it's gonna test the values returned is gonna be a sum as we expect it to. And then we wanna make sure that we export that sum into a test file. And how should you name your test files? Typically, you're gonna wanna name them whatever your actual code's name is, but you want to put test before it as well. So if it's functions.js, which granted probably isn't the best name, you want to make it functions.test.js. And then so this is our sum function. This is the function we're going to be testing. And then we have to make sure we import that function as well so that we can test it. And then you might be seeing this it and be like, what is this doing? That's just some Jest syntax that actually tells our code that we should be testing it. And it should also be have a descriptive name of what our code is going to be doing as well. So I mentioned we should have arrange assert, arrange act assert as our format for writing test cases. And we'll kind of just comment that here so we can see what each one does. So first thing we're going to want to do is have some data that's going to be turned into our function. So we can say like let x, I guess, equals 1. And then we can do let y equals 2. And these are going to be the inputs we end up using for a and b in our sum function. I guess better names would probably be a and b. And then we can go ahead and have our expected value. So we can call that expected value. Pretty creative name. We'll set that equal to 3 because obviously we should know by now that 1 plus 2 equals 3. So that's it for our arrange. And what that arrange is doing is just kind of creating all of our variables that we're going to use in our test case, as well as our expected value. And then we want to have our act. And what our act is going to do is it's going to call the function and get a return value. So again, we can have let return value equal the sum is calling the function, and then a and b. Oop, that was a 1. A and b. So that's it for our act. Again, this is a very simple test case, and what this is doing is just getting the return value of sum of a and b and putting that into our return value. And then our assert is where we actually kind of use all of our code so far in our test case. So we want to make sure that the expect, and that's just some syntax for Jest, and that'll tell you kind of like it'll allow you to set things like I guess to be is one, to be truthy is one, to be falsy. This is just gonna be how you're actually making use of your test. So we can let our return value, and then we're going to want that to be our expected value. And then we can actually go ahead and run npm test now and see if this function works as expected. We have 2 functions passed. That's on my end because I already had a different function, a test function that I created, which we'll go to in a second. But we can see that this one passed. If we were to, I guess, change some values, we should see what failing a test case looks like. We should see that 1 passes and 1 fails, and we'll go ahead and look at what that failed test case looks like. Here we can see what our function is. So this is kind of going to be helpful for debugging. We can see the expected value was 2, and then the received value was 3. So we can see that that's kind of wrong. We know that it is wrong for that reason. So we can go ahead and fix that and make sure that it passes. Sweet. So that was a very simple test case. We'll go ahead and do one slightly more complicated test as well. And I'll also add that you can do a lot of different tests. This is just testing a simple function, but our next test is going to be a little bit more complicated. And we're actually going to cover testing a fetch request. So I wrote a function, something that seems a little bit familiar to us. and I'll go over kind of what this code is doing, and then we'll go ahead and write the test case for that. So get recipe name is going to be a different function, and it's going to be using a fetch request. Take note here how this is an asynchronous function. That'll be important later. So what this code is actually going to do is it's going to hit this endpoint. It's going to set that JSON value that's returned and set that equal to data. And then because this is just going to be a test case, we're going to return that the first object in our array that gets returned. We're just going to check the recipe name of that. That'll be more visible and understandable in our actual test case. And then we just have to make sure we export this function as well. And then here I have some, I guess, again, starter code, and this is just going to save some time for all of us. But here we can see that it follows the same format of arrange, and then we'll go ahead and add the act and assert in a second. So describe is a new kind of word we're seeing now. That's a feature of Jest, which is the testing library we're using. And what that does is it allows you to group unit tests together. So maybe if we had a bunch of different functions that were all hitting this endpoint, we could put that together and say that in our describe. And that's gonna work great for us for when we want to group unit tests. And then we have some mock data here. This is just going to be, I guess for this demo, it's not full mock data, and you're probably not ever going to want to do full mock data because, again, that's going back to your data is always going to look different. If we had 100 different recipes, you aren't going to want to mock all of them. So you can always just do a subset of your entire data, and that should work great for your tests. So here we just have two objects. We have one that says pasta and one that is loco moco, and then none of this else is really important. And that is because we're only returning the recipe name from the first element, or I guess our first object. So again, this is in our arrange. We're setting mock data here. And then now we're getting into some slightly more complicated code. So I'll just go to briefly talk about what this is doing. And whenever you're writing your own fetch request, this is pretty easy to find online. Just look up how to write a fetch request with Jest, and it should look something like this. So what global fetch is doing is that is actually going to be kind of mocking our actual API call. We don't always want to have our tests actually hit our API call, because if we were doing like a post request and we wanted to test that, we wouldn't want to necessarily post that data into our database. So writing a mock is kind of a good way to do that as well. And plus, it actually doesn't even need to hit our database because we have set this mock data here. This is kind of what would be returned from our mock data theoretically. And then jest.function is again a function of Jest, and that doesn't do too much besides allow you to return a function inside of that. And then here, because this is an asynchronous function and it's await, we're going to need to return a promise. And by having that dot resolve, it's actually going to just assume that it gets resolved eventually. And then here, JSON is going to be a value, and it's going to return the promise from our mocked data that we set up here. It might be a little bit confusing, but breaking it down to smaller pieces should help a little bit. And now we should be good to actually go ahead and finish off this test case and see that it works. So again, as mentioned earlier, it is just a keyword you can use, and that's how you're going to want to describe your test case. So we're going to say that it returns the first, or the recipe name of the first object in our data. I cannot type. Again, this is also going to be an asynchronous function. And then our act is going to be kind of important. And remember, this is where we're going to get our actual data. So we're going to set that to a value. We can do it, call it actual. And then as it's an asynchronous function, we need to await. And then I believe our function was get recipe name. And that was, yeah, get recipe name. So now in our act, we actually set the value of actual. and we can go ahead and use this actual in our assert. And there are a lot of different things you can do with your asserts. I guess I'll briefly show one and then I'll show another. We can test a lot of different things. We don't have to test necessarily that the data is returned appropriately. We can test that, say if we might just want to test that our endpoint gets called. We could do the function to have been called times and then 1. And this should just say that our fetch request here should get called only once. You might find this unit test helpful when like paired with a use effect hook, because as remembered, those can sometimes run multiple times if data changes. So that's a good case of when you might find this useful. But we can go ahead and run this npm test. We'll see that this passes. Maybe if we change this value, we should see that it fails because it doesn't call twice. We could actually probably also just do this and I won't worry about that for now. And then if we did want to test our actual data and check that it is returned properly, we could expect actual kind of to be, and then whatever our first recipe name was. So I guess in this case, it would be pasta. And we could do that here and check that this works as well. So by running npm test, we see that it works as expected. One thing I actually didn't do, but I probably should have done is you don't want to put data in here. This would be better suited as more data we put in our range. So we could have done something like let expected equal pasta. And then we put that expected in here. And then we run that and it should work as expected. So those are the 2 unit tests I'm going to talk about. This one's quite a bit more complicated. And it's understandable if it doesn't all make sense right now. The best way to actually learn unit tests is actually by writing them. And I'll also add that there is a lot of more you can do with unit tests. You don't have to just test, I guess, that a value is returned. You can test all sorts of different things. You can test, I guess, kind of really whatever you want. There's a lot of information on Jest that the documentation. So we'll go ahead and make sure we link that as well. Oops, I wasn't supposed to stop sharing. I was supposed to go back to the slides. And then we should be good to move on to code etiquette.
Yeah, thanks, Cole. So now we're going to be talking about code etiquette, which is basically like best practices when working with code, especially when working with other people. So these first 2 tools we're going to be talking about are code formatters and linters. And they're like great tools that you just set up once and then help keep your code base consistent and very easy to read. So a code formatter will automatically style your code for you. So this will look at things like single quote versus double quote, semicolon versus no semicolon, 2-tab indent versus like 4-space indent, and just things like that may be inconsistent between like different developers or even within like one person's like file. And a code formatter will just take that and automatically format all your code so it looks the same across all your files. So when working with JavaScript, Prettier is the most popular code formatter. And just like a lot of the tools here, it's a node package. So you install it as a dev dependency. And then in order to run it, you can just write npx prettier -- write, and that will automatically reformat all your code to match however you set up Prettier to make your code look. But to really get the most out of Prettier, I'd highly recommend installing a Prettier extension on your IDE. So if you use like VS Code or Vim, a lot of pretty much IDE or any text editor will have a Prettier extension because it's so like ubiquitous. You can just install that and turn on format on save. And what that would do is basically anytime you save a file, Prettier will automatically format your code. So you don't even have to write like a command anymore. So highly recommend that both for solo projects and for group projects, just because it helps keep all of your code formatting consistent. And then the next tool we're going to talk about are linters. So a linter won't format your code, but it will tell you kind of best practices to use and some good formatting techniques to use when writing your code. So as that first bullet point says, linters are development tools that enforce standard formatting and detect code smells. And a code smell is essentially like code that technically works, but could lead to bugs later on or might not be a best practice. So pretty much you're almost definitely will be using a linter on your team just because it makes code more readable. It keeps formatting consistent within the team, and it makes it a lot easier to catch bugs just because of linter will know kind of when you're writing code that might not work properly. So in addition to looking at the stuff that a code formatter will look like at, linters might also tell you, hey, this variable isn't changing, so you might want to use const here instead of let, or hey, you make this variable, you never actually referencing it, why don't you just get rid of this variable? So it tells you a lot of good practices like that. So a linter won't actually, a linter might be able to automatically change some of your code, but a lot of that, it's just going to tell you, hey, this line of code needs to be fixed, here's how you fix it, and then you do it yourself. But you can use a linter and a code formatter together. So they work well together, but they do serve two like separate functions. And then actually, I forgot to mention ESLint is the most popular linter for JavaScript. So that's also a node package. You download it and then you use it. And then node packages. So as you can tell, we use lots of node packages when working on web development. So it's good to know when you actually should or shouldn't be using a node package. So a couple tips on like when you might need a node package is when you're writing repetitive code. So if you find code that just repeats the same logic over and over again, and you think that it might have already been written by someone else, you can just look at Node for that. If you're implementing a general feature, like if you have a calendar, that's a really popular one, like on your website, or if you have like a clock on your website, you'll find that a lot of those like features that don't come built into HTML are probably implemented in some Node package. Or if you want to have some more advanced functionality in your app, like if you want to have like a really complicated form, that's where things like React Hook form or Formate come in. So that kind of helps you take a more advanced programming logic and simplify it, because a lot of the complex stuff is handled by the Node package. So if you run into any of those like three cases, it's a good idea to just look at npm, just Google it, and see if there's a Node package that exists to make your life easier.
All right, awesome. Thanks, Vance. So now I'll be talking a little bit more about kind of some practical advice for working with teams and keeping your code organized once we move into project teams next quarter, since we're kind of at the back end of bootcamp here. So the first thing I'll kind of touch on is the GITIGNORE file. This is something that you may have seen floating around your React app, or if you've used GitHub before, you may know what this is. But it's a super helpful file that we can use when working with a lot of these node packages that we've been talking about, and when we kind of want to decide things that we do and we don't push to GitHub. So .gitignore is basically just a file that tells Git on your computer which files that you want to ignore and when you're making commits on your machine. So it's essentially just a file that's going to have a list of a ton of different file names inside of it, and any file name or directory name that's inside of the GITIGNORE file, it's not going to get committed and it won't get pushed up to the cloud. So in general, a GITIGNORE file should have been created when you ran create React app. when you initially started using React, and it pre-populates it with a lot of kind of files that you'd want to ignore anyway. So you may not have had to mess with it so far. If it didn't get created or you deleted it on accident, it's pretty easy to just make a file and name it .gitignore, and it'll serve kind of the same purpose that file did. So specifically in our project teams, we're going to be wanting to use this file to not send anything in our node modules directory to GitHub, because this is stuff that it's just going to be a ton of extra files that everyone can access by running npm install and just pulling those files themselves from npm instead of putting it into our GitHub repos and kind of slowing down the push and pull operations. So that's kind of the main thing we'll be using it for. So another thing I'll talk about is just some other Git etiquette when working in these larger groups. We talked about this a bit at the beginning of the bootcamp sessions on why Git's useful and things like that. But Git can be super helpful, just letting us organize our code and work together on code when we know how to use it correctly. So a couple kind of general guidelines you want to follow when using Git in our project teams. So when we're making commits, we'll want to kind of group similar files and changes that we're making into individual commits. So basically what this means is on project teams, you're not going to be building, an entire website the night before, like your assignments do or whatever. You'll be implementing individual features, maybe making a bug fix or adding a new page, kind of incrementally one at a time. And so you'll want to make individual commits kind of with these fixes or updates as you go, just so that everything stays organized and you know what's happening in your website. And then you want to keep your commit messages succinct and informative, just so you can look back and see what they mean in the future. And then we kind of follow the same philosophy with branches as well. So instead of just having maybe, if us three were in a team, having Cole have his own branch, if I had my own branch and I just do everything I code on one branch, it's not a very good practice. So I would want to make a branch for every individual feature or bug fix that I make. And then again, just create a short, meaningful name that I'll know what it means when I go back to it in the future to update those changes. And then finally, pull requests. So you all are probably a little bit familiar with pull requests. We've been using them throughout Bootcamp to turn in code so that we can kind of review it for you. But they become super helpful once we're in project teams and maybe you have 6 or 7 people who are working on separate things at the same time. And you need to review kind of individual aspects of the website. Pull requests are super helpful to keep you organized and keep our project teams on task or on track. So when you're making a pull request, you're going to want to make sure to write a good description for it. So this can be a little bit longer. We don't need to write essays or anything, but just kind of describe the changes that you made, maybe what the code that you're requesting to merge is kind of doing. And then you could attach images as well. So if you're making like a CSS or design change, maybe attach a screenshot of what you see on your end. So when people are testing it, you can compare and make sure it looks the same. Things like that. So just make those as descriptive as possible so everyone's up to date on what's happening. And then kind of the final thing I'll talk about with some general etiquette that we want to think about is commenting code. So we talked about this just a little bit so far in Bootcamp, but I do want to kind of emphasize that commenting code is something that's really important. It's going to help us a lot on our project teams. Because feature readability is just a super common issue that we're going to run into once we're actually on these larger project teams. Because we'll be making files and maybe adding one thing to them and coming back, a month down the line to add new features to it, maybe fix a bug in it, and you're going to be seeing files that you've never touched before. People are going to be reading your files for the first time after you coded them a month ago. And we just want our files to be readable, not very cryptic, so that we don't have to be sending messages back and forth asking what's happening on line 5. People don't understand. It'll just slow down our development process overall. So there's no strict guidelines or requirements for commenting code, but some good general formatting to follow. So just throw a quick comment at the top of each file explaining what the file does overall, why you made it, its purpose, things like that. Each individual function you write, again, just kind of describe its purpose, what specifically you're accomplishing with it. That way someone can just use that function without having to understand how it's actually completing its intended purpose. And then if you have any super complex lines, so maybe you're doing a ton of math, you're writing a complex map for, JSX or something like that, just comment those lines so, someone doesn't have to spend a half hour writing tests and figuring out what your code's doing. And then possibly most important, make sure you remove like old code that you comment out. So, we all know it's a super common process when developing to get frustrated with a function, copy it, comment it out, and kind of restart the whole thing from scratch. That's totally a good way to do it. But once you do kind of get everything working the way you want it, we don't want to be like saving old code in case it breaks and stuff like that. So we just want to delete that code before we send it to GitHub so people can read it. But overall, kind of the main goal we want to think about is just making things as readable as possible for people and just making our lives as easy as they can be down the road.
Sweet. So now we're gonna actually wrap up. Hopefully this is a lot quicker and shorter than most of the in-person boot camps. Without having a thing like a Kahoot or waiting around, we can kind of get through these a little bit quicker. So we do have a few reminders. The first one is going to be that milestone 4 is going to be due the final day of Thanksgiving break. And then the last reminder is that milestone 5 is going to be due on December 20th, 2021. And this is a hard deadline. So you really want to make sure that you're getting your milestone 5 done, honestly, probably well before that due date so that we can go ahead and review it. And this is going to be important because you actually do need to complete the milestone project, I guess the bootcamp project, before you can be put on your project team. So you might get an email saying like, this is the project team you're on based off of your project feedback form. But you're actually not going to be allowed to be on that project until you complete the bootcamp project. So keep that in mind. If anything comes up, we'll still be available over break. Reach out to us on Slack, or we will be holding our office hours on Sundays still from 11 to 12 a.m. on Pacific Standard Time. So definitely stop by. Let us know if you have any questions about anything related to bootcamp or the project. We're happy to reach out. We're happy to answer any questions you all have. And yeah, that should be it. This is our final session of bootcamp. Congratulations again. I know this was a part of the last thing, but we gotta flex our creation again. It was super good at seeing you all at bootcamp. Hopefully you guys found this informative and learned a lot here. Hopefully it'll also prepare you well for the project teams. And I think once the projects actually start, you'll kind of see a more practical application of a lot of the stuff we learned in bootcamp. So congrats on making it this far. This wraps it up, and it was super kind of fun to see you all and see all of your projects as well. Good stuff, everybody, and that should be it.